Today we're going to learn how to do some tan graphs. So first thing we need to remember is that tan x is equal to sine x and cos x. So when cos is 0, tan is undefined. Cos is 0, tan is undefined. So tan is going to be undefined at all the multiples of pi on 2. So we'll just label that. Tan is going to be 0 when sine is 0. So that's the multiples of pi. So at 0 and at pi and at 2 pi and at minus pi and at minus 2 pi. And then what we do is we join this up smoothly, and a tan graph looks like this. So it's quite different, but you would have seen them last year. So the difference between tan and cos and sine is this one, it repeats every pi units. So the period is pi, but for cos and for sine, it's 2 pi. The range is r, all the numbers, because it keeps going. It has vertical asymptotes at the multiples of pi and 2, but if we have shift across, that's going to change. So the formula we use is 2k plus 1 pi on 2. So what we're saying here is that if k was 0, we'd get 0 plus 1 pi on 2. And that is where the first one is. What about if k equals 1? We'd get 2 plus 1 is 3 pi on 2. And that's our second one. If we looked what happened when k was negative 1, we'd get negative 2 plus 1, which is negative pi on 2. And that's why we have this one. So the k is just the number of the asymptote it is, whether it's the below 1, that one at 0, and we could just keep going and count through. And then our intercepts are where theta equals k pi. So if k is negative 1, negative pi. If k is 0, it's at 0. If k is 1, it's at 1. If k is 2, it's at 2. So that's what our tan graph looks like. But sometimes it's going to be a little bit different. So it's going to be this A value out the front, and we know anything out the front, this is a dilation factor A from the x-axis. And this is dilation 1 on n from the y-axis, inside and opposite. So the period for tan is pi. So the period for tan nx is pi on n. So for sine and cos, it's 2 pi on n. For tan, it's pi on n. The range is r. And my vertical asymptotes are going to be at 2k plus 1 pi on 2n, because this dilation factor is going to affect where the asymptotes are. So you can do it by the formula. I'll show you another way in a moment when we go to draw it. And the intercepts are at, well, before it was at multiples of pi. Now it's going to be the multiples of pi over whatever that value n is. So that's a little bit different, isn't it? So let's have a look. I don't really want to draw anything there, I don't think, but I think I probably want to draw something here. 2 tan 3x. So the 2 at the front, the dilation for x, it just gives us an upward stretch. So I'm not going to worry too much about that. But this is a dilation 1/3 from the y-axis. So what I think is my original asymptote was at pi on 2. So now it's going to be dilated 1/3. So it's going to go to pi on 6. 3 pi on 2 is going to go to 3 pi on 12 or pi on 4. So what I do is I just draw it as normal. Put my shape in, because my drawing's not that good, that the dilation from X we can't really see. But then I think when we look to the asymptotes, everything's been taken 1/3 in. So this first one here will be at X equals pi on 6. And the next one would be at, well, 3 pi on 12, so I'm going to say pi on 4. Which makes me realise this is wrong, isn't it? Because, sorry for the pause, we said the dilation was 1/3. So if I times this by 1/3, I actually get 3 pi on 6, which is pi on 2, and that sounds better to me. So I'm going to do pi on 6, and then I'm going to do pi on 2. And that's all we've got there. On the other side, they're going to be at X equals minus pi on 6 and X equals minus pi on 2. So we basically think we're counting in pi on 6s. So pi on 6, this one will be 2 pi on 6, which is pi on 3. 3 pi on 6, which is pi on 2. And the last one will be 4 pi on 6, which is 2 pi over 3. So I've kept my same drawing. What I'm doing is I'm just changing the labels because the dilation from the y-axis is the thing that is important. So my period now is pi on 3, and that's true, isn't it? Because if I go from there to there, it's 2 pi on 6 or pi on 3. My range for tan is always R. My vertical asymptotes are at 2k plus 1 on 2n, or 2 times 3. So they're at 2k plus 1 on 6. So I could substitute in values for k to get these, but I just did it through the dilation factor. And my intercepts, they're going to be at, what were they, k pi on 3. So they're at pi on 3. And then again at 2 pi on 3, and at minus pi on 3, minus 2 pi on 3. So that is how we draw a tan graph. You can either use the dilation of this 3 here to have everything 1/3 of what it was before, or if you'd rather, you can use these formulas to work out where those intercepts are. Either way, you can now go and do from 6J, questions 1, 2, and 3. So do those properly, get it right, and that will be just one lesson's worth.